Welcome to educational channel of sureshbhattclasses. We are going to learn NCERT class 10th chapter 1 real numbers topic 1.3 the fundamental theorem of arithmetic. Every composite number can be expressed or factorized as product of primes, and this factorization is unique apart from the order in which prime factor occur. Also, if we decide to keep factors in ascending, then factors is unique. Let us learn the prime factorization of some numbers. By example, the prime factorization of 34 lakhs 92,720. So we do like this. As the number ends with 0, so it is divisible by 2, and 2 is the first prime, so we divide it by 2. It divides. 3 divided by 2 is 1. Then we carry 4. It divides. 14 by 7. Then we divide 9 by 2, which it gives 4, and balance is 1. We carry 2, it divides for 6 times. Then we divide 7 by 2, which gives 3, balance is 1. We carry 2, it divides for 6 times, and then 0 is divided by 2 for 0 times. So this is 17 lakh 46,360. Now we again divide it by 2 because it is again even number. 17 is divided by 2, it goes for 8 times, balance is 1. Then 14 is divided by 2, which is for 7 times. Then 6 is divided by 2 for 3 times. Then 3 is divided by 2 is 1, and balance is 1. We carry 6, it divides for 8 times, and again 0, we divide 0 by 2, it gives 0. This gives 8,73,180. We again divide it by 2. 8 is divided by 2, it gives 4. Then 7 gives 3, and balance is 1. 13 is to be divided by 2, this gives 6, balance is 1. 11 is divided by 2, it gives 5. Then 18 is divided by 2, gives 9, and 0 is 0. Again we can divide it by 2. 2 times 2 is 4. 2 times 1 is 2, and balance is 1. 16 is divided by 2, this gives 8. 5 and divided by 2 gives 2, and balance is 1. 19 is divided by 2, gives 9, and balance is 1. We carry 0, and it divides it by for 5. So 2,18,295. Now it is not divisible by 2. So we check whether it is divisible by 3. So we add all the digits. The sum of the digit is 2 plus 1 is 3 plus 8, 11, 12, 13, and 9, 22, and 5, 27. So it is divisible by 3. As it is divisible by 9, it is divisible by 3. So we will divide it for 3 times by 3. 21 divided by 3 gives 7. 8 divided by 3 gives 2, and balance is 2. Then 22 is divided by 3 gives us 7, and balance is 1. 19 divided by 3 gives us 6, and balance is 1. It gives 5. We further divide it by 3. 3 times 2 is 6, balance is 1. 3 times 4 is 12, balance is 0. We carry 7. 3 times 2 is 6, balance 1. 3 times 5 is 15, balance is 1, and again 3 times 5 is 15. 24 divided by 3 gives us 8. 2 when divided by 3 is not divisible, so 0, and we divide 25 by 3, it gives us 8. Balance is 1, and 3 times 5 is 15. So it divides for 8080 times. So it divides for 8085 times. It is further divisible by 3. So we divide it again. 3 times 2 is 6. Balance is 2. 20 divided by 3 gives us 6 times 3 is 18. Balance is 2. 3 times 9 is 27. Balance is 1. 3 times 5 is 15. This gives us 2695, and the sum of digit is 22, so it is not divisible by 3. We divide it by 5 as it ends with 5, so it is divisible by 5. 5 times 5 is 25, balance is 1. 5 times 3 is 15, balance is 4. 5 times 9 is 45. It divides it, and the quotient is 539. Now next prime is 7. We just check it whether it is divisible by 7 or not. 7 times 7 is 49. Balance is 4. 49 divided by 7 is 7. So our quotient is 77. Now it is further divisible by 7. 77 divided by 7 gives us 11. Now we have all the prime factors. So these prime factors are, this gives us 2 multiplied by 2 multiplied by 2 multiplied by 2, that is 2 for 4 times, and 3 multiplied by 3 multiplied by 3 multiplied by 3, 3 is also for 4 times, multiplied by 5 multiplied by 7 multiplied by 7 multiplied by 11. So if we write in powers, it will be 2 to the power 4 into 3 to the power 4 into 5 into 7 to the power 2 into 11. Or we can write 2 to the power 4 into 3 to the power 4 into 5 into 7 to the power 2 into 11. This way we do the prime factorization, and this is unique. Now if we have kept in ascending order, so this is unique in order as well. Finding HCF and LCM by prime factorization. HCF of given numbers is product of smallest power of each common factor of given numbers. Here it is important that each common factor, and in LCM of given numbers is product of greatest power of each prime factor involved in the given numbers. Here each is important. Here we have to take each prime factor, and that too of greatest power of each prime factor involved in the given numbers. We will learn it by some example. We will find LCM and HCF of two numbers. So we are going to find HCF of 72 and 120, also LCM of 72 and 120 to learn it. So first we take HCF. We first prime factorize 72 and 120. So 72 we are factorizing. We divide 72 by 2. This gives 36. We again divide it by 2. This gives us 18. We further divide it by 2. This gives us 9, and 9 is divided by 3. This gives us 3 and 3. Now we factorize 120. This on dividing 120 dividing by 2 gives 60. Then again on dividing by 2 we get 30. Again we divide it by 2 we get 15. It is divisible by 3, so we divide it by 3. This gives us 5. So 72 equal to 2 to the power 3 and 3 to the power 2, and 120 equal to 2 to the power 3 into 3 into 5. Now we have the prime factorization of 72 and 120. Now as per the procedure, SCF is the smallest power of each common factor. Here common is important. So what we find here, 2 and 3 are common in the prime factorization of 72 and 120. So, and we have to take the smallest power of prime factorization. So here 2 has the power 3 in both the cases. So HCF, in SCF we will be having 2 to the power 3, and again one has 3 to the power 2 and other is having 3 to the power 1. So we will be having the smallest power. So this is 2 to the power 3 into 3 to the power 1 or 3. This is our SCF. This is equal to 24. So 24 is the HCF of 72 and 120. Now we find LCM. LCM we have to take greatest power of each prime factor. So here 2 is common both the prime factors, and we have to take the greatest powers. So 2 to the power 3 is in both the cases, and then we will be having 3 to the power 2. This is greatest. In 72, 2 to the power 3 is greatest. So we will be taking 3 to the power 2. Then we have to take each factor. So the only factor remains is 5. So we take 5 also. And now our LCM will be 2 to the power 3 into 3 to the power 2 into 5. This gives us, on multiplying all these, we get 360. So HCF of 72 and 120 is 24, and LCM of 72 and 120 is 360. We go for one more example. We'll find HCF and LCM of 216 and 324. So we prime factorize 216. On dividing 216 by 2 we get 108. We further divide it by 2. This gives us 54. This is further divisible by 2. So we divide it by 2 and we get 27. And then now it is not divisible by 2. It is divisible by 3. So we divide it by 3 and we get 27 divided by 3 gives us 9. And again it is divisible by 3. So we divide it by 3. Now we prime factorize 324. 324. On dividing by 2 we get 162. This is further divisible by 2. We further divide it by 2. It gives us 81. Now it is not divisible by 2. We divide it by 3. This gives us 27. We further divide it by 3. This gives us 9. This is further divisible by 3. We again divided by 3. It gives us 3. So we have done the prime factorization of 216 as well as 324, and we write 216 equal to 2 to the power 3 into 3 to the power 3, and 324 equal to 2 to the power 2 into 3 to the power 4. Now we have to find HCF. HCF is the smallest power of each common factor. So we have to find the common factors. 2 and 3 both are the common factors of given numbers, and we have to take the smallest power of these. So smallest power of 2 to the power 2 and 3 to the power 3. 2 to the power 2 into 3 to the power 3 is equal to 27 multiplied by 4, that is 108. So HCF of 216 and 324 is 108. Now we find LCM. LCM is greatest power of each prime factor. So greatest power of 2 in both the numbers is 2 to the power 3, and greatest power of 3 is 3 to the power 4. So our LCM is 2 to the power 3 into 3 to the power 4. This is equal to 648. So HCF of the given numbers 216 and 324 is 108, 108, and LCM is 648. This way we can use the prime factorization of given numbers to find HCF and LCM of given numbers. Here completes this video. Please like, share and subscribe to this channel.